So can we all see my screen?
Yes.
Okay, so I'll just start from the beginning. Open your phone. Okay, so this is where I'm going to be starting from. So all of these ones are just introductory parts, the control and everything. I think we've talked about that one. So for refresher's sake, I'm going to be starting with the basics that you need to know about R and data types, right? So like I said, when you want to make you when like I said, basically for using R in your various career paths and in your various field, you would notice that most people who use R, the people who use R work in different firms and different places, right? So basically, researchers, statisticians, biostatisticians, different industries of different places uses R, and that's why R is very keen and very necessary that we learn the programming language. If we are not learning Python, we are learning R. Getting the two programming language knowledge or basics is also a plus for us. So for those who want to go into research work, probably further for masters and PhD. For those who want to work in different fields that required R, so this is like a stepping stone for you to right learn and then project yourself. So basically, we are going to be starting with the basics of R syntax, and that's the variables and data types. So what's R syntax is designed to be simple, intuitive, making it accessible for beginners while also powerful for advanced users. So here's an introduction to variables and data types in R. So I made an instance in our last class. I said that when you go into, let's say somebody walks into ShopRite to get an item, right? And probably milk. We know that milk is something we put into the tea that dissolves and maybe we take with Lipton that is consumable, right? So but there are different brands of milk. So if I go into a store and I say I want to buy milk, milk can be anything. The receptionist will ask me or the cashier will ask me what brand of milk do I want to buy, because it's the brand that determines the content that is inside. So that's what variable name does for you, right? So if I come to R and I tell R I want a numeric value, right? So R will ask me, I can have many numeric values there, but R will ask me which of the numeric value do I want. So your variable name determines, right? What the your variable name determines how you access, or it helps you access a stored what information in R. So if you want to store an information, whether it's a character vector, a numeric vector, a logical vector that you would want to access or make reference to later in your analysis, right? It is better you use a variable name to store it. So a variable name is like a household name. So whenever I want to access this, I'll go to my variable name and access it. So if I store a large amount of information and I want to access it in R, because I need to assign it to a variable name so that whenever I want to go through it, I'll be able to use that variable name to access it. So if I don't store it with a variable name, I'll not be able to access it later in the future. So for better understanding, a variable name is just used to house informations. It could be numeric, it could be character, it could be logical, it could be date and time vectors or numbers or information that allows you make reference or manipulate data later in your analysis, right? So now variables are used to store data like you can see in the name there, which can also be later referenced or manipulated. To create a variable in R, use the assignment operator, that's the less than sign and the parentheses, or you can actually use the equals to sign. But for R, it is preferred that you use this assignment operator, this one that my cursor is in now, the one with the less than sign and the parentheses in front. You could also use the equals to sign, but the equals to sign is mostly used in Python. So for those who know or have idea about Python, right, you know that most of the time that is the assignment operator that is used to assign variable names in Python, right? But for R, we should stick to the less than sign and the parentheses in front of it. So what's assigning a variable name or a variable assignment, right? So using the preferred assignment operator, so that is this. Let us now go and assign. Okay, let us now look at variable names naming rule. So now number one, before you can give an object or give a stored information a name, okay. Hope you are listening. Hope you are following. So please leave an emoji, an emoji. If you are following, drop an emoji. Let me know that you are following. Okay. I don't let me know my network. So before you name or before you can assign a variable name to a particular information in R, you should be able to know that the variable names in R follow certain rules. And if you don't know those rules and you actually go against those rules, you would not be able to store information using that specific variable name you want. So the naming rules include that number one must start with a letter or a period, not a number. A period means full stop. So whenever you hear a period in R or wherever you are, whichever programming language you are doing, and you hear about a period it means a dot, a full stop, right? So your variable name in R must start with a period or a letter, but it cannot start with a number, neither can it start with a space, right? Then the number two is that it contains letters, numbers, period, and underscore, but no word space. So even if I'm trying to write a compound word, like combining two words together, or I want to give a particular information, Lagos Abuja, or I want to store it with a particular name, maybe my name. I want to store a particular information with my first name, my second name, and I'm storing it with Felicity Chinaza. So the space between Felicity and Chinaza should not be an empty space. So they should either be a period, that's a full stop that is able to connect Felicity and Chinaza together, or there will be an underscore that will be able to connect Felicity and Chinaza together. So number one rule says that a variable name must not start with a number. So it could start with a letter and it could start with a period. And number two says a variable name can contain letters, it can contain numbers, it can contain periods, and it can contain underscore but cannot contain word spaces. Number three says R is case sensitive, meaning that however you write R. So if I start writing my variable name with a capital letter and I want to reference that variable name later, I want to reference the information stored in that variable name letter, I must write it exactly the way I wrote it initially. So now let's go into R and practice all of these rules that we are talking about. So now I'll be assigning names, variable name to R. So let's understanding variable name. So I'll say understanding variable name. So I'll say let's assign um 10 10 to a variable name. So I'm saying x less than. So remember that this is your preferred assignment operator in R, right? So I'll be assigning x to 10. So when I run this, so when you want to run, either you highlight and run, or you put your cursor in front of your code and press control enter, right? So you can either highlight and run on your system, or you can just put your cursor, ensure your cursor in front of the code you want to run, and then press control enter. Control enter enables you to run your code. So you will notice here that my value x has already been assigned to my value 10 has been assigned to my value x, right? So now let us practice. I can also use the equals to sign, which is also acceptable in R, right? But our preferred operations assignment is the less than sign and parenthesis. So if I decide to add y, So I'll say y is equal to 10, 11, and I run it. You see that y 11 has already been assigned to y, right? Now let us understand naming. Right, number one naming rule says um every variable can must begin with every variable must begin with a letter or a period. Right, so now let's give an example of it. So now if we say every variable must begin with a letter or a period, I would come down here and assign a variable name to it. So I would say let's say paid class. Maybe just use paid, and I'm going to be assigning value to it. So I'm going to be assigning students to paid. So you could see that at the beginning, this variable name met the criteria or met the naming rules, right? Which began with a word, with with a letter, right? So I'm assigning students to paid. So when I run this, you see that it will work, right? It has already been stored here as a text. Now let me assign a period. Like I told you, a period means full stop, equal full stop, like dot. That's when whenever you hear about a period in R or in Python, you should know that they are talking about full stop, right? So if I start my variable name with a full stop, so all I need to just do is just to put my full stop, and I would say let me assign score. So I'll say maybe 30, 35, right? So you can see that this one, the variable name began with a full stop, right? And now continue what? With a letter, with letters, right? So if I run this, you can see that it will run. Another, the one that they said would not work is beginning with numbers, right? They said your variable name must begin with a letter or a period, but not what? Numbers. Let me put the one here, but not numbers. So if I go down here and I start with a number, like let's say I start with today's date is what? 13 or so, or I think today's 13. I'll say 13 July. Let me just put it like that. 13, yes, June. Okay, 13 June, right? And then now say let's assign a variable. Let me assign false logical variable to it. Right. When I run this, you can see that there's an error with it because it has gone against the naming rule for variables in R. So even if I try and remove it and put just one number and I still run, you can see that there's an error because I have gone against the naming rule that R has specified, right? So the next one says another naming rule. Okay, let me leave it there. So false. So I'll just write comment here. Error in variable name, right? So now the next one says the variable name can contain can contain letters, numbers, underscores, but not spaces, right? So now let's give a variable name You we have seen the one that had we have seen a variable name with letters like with cell here it ran. We have seen a variable names with it can contain numbers in between but not at the beginning. So now let's create a variable name that contains numbers now. So I would say root tree, right? This one contains number. Then I would say football. You can see that it ran. Then it contains number, but the number is at the suffix, at the ending part. So you could also have a one that contains number in between the R. So let's say I want to use Katrina. I could just say Katrina. You can see that there's a number in between the variable name, and I'll run it, it will work, right? But you can see that when we did the number first before the letters, it didn't run. But the number can exist in between what your variable name or even at the suffix and at the end of your variable name, right? The other one says that it can contain underscore but not spaces, right? So let's say I want to combine two names together. Let's say I want to combine root ob, like, or okay, I want to store a name. I want to store um let's say, okay, let's say I want to store an information using Dano milk, right? And I don't want the Dano milk to be together, right? Let's say I want to store an information, maybe measurement of Dano milk, right? So I could just say I'll give it a variable name Dano milk. I could write it like this, right? And it will run. So I'll give it Dano milk. So let's say how many kg does the Dano milk measure? I could now say maybe it measures 500 grams. Sorry, 500. If I'm using numeric, doesn't 500, right? So now if I run this, it will work, right? If I still decide to put underscore here in between Dano and milk, it will still run. But if I decide to just leave here open and just leave space right in between Dano and milk and run it, it will give me what? Error. So you can see it, unexpected symbols in Dano what? Milk. So I'll come down here and I'll say I'll now give it a message, error in variable name, because you don't allow what spaces. Then the last one says that variable name does not, okay, variable names are case sensitive. Right, so let's say now let's use all of one of the variable names that we have created, right? So let's say from the example I did, I was starting with line row 7. You can see it here, where I assign students to paid, right? So now I would now say, so let's now uh, print out the student. I want to see the information that paid is housing, right? So let's say I started this with small letter P, and all my letters are in lower are in small letters, right? And now I want to reference back to this paid, right? So I can make use of the value that is being stored in paid, right? So if I decide to say print paid in capital letter, instead of the way I wrote it here, where I started with small letter, it will not run. So I'll just come down here. If I say run, it will give me error because it will tell me paid not found. So when you are trying to save an information using a variable name, you should ensure that if the letter if what I saved it with were all in small letter, when I am referencing back right to that information, I should ensure that all my letters are placed in in small letter, right? So if they're in capital letter, I should ensure all of them are placed in capital letter. And if they are in the first, if you use the first word of the first letter of each word should be in capital letter. You should ensure that when referencing that particular variable name, each word of each letter of the word must be in what, in capital letter. But in this scenario, you can see that all my letters here are small letter. And in this one, when I wanted to print it out to see what paid is housing, I made my P a capital letter and it's still giving me error. So if I decide to still change it and say, okay, let me put um everything in capital letter, since paid is still paid, the only difference between the two of them is that the first one is in small letter and the one that I'm referencing is in second is in capital letter, right? Let me run it and let's see if it will work. When you decide to run it, it will not work. It tells that object paid, not what found, right? So if I come down here and say print paid, so I now go back to how I saved it, right? Say print paid. When I run it, right, it has given me students, right? So now for that other page where I use capital letter, I could still save a variable name, right, with that same page, but it will be in capital letter. Because when you now want to reference it, I will know that okay, these two names are the same thing, but the only differentiating factor is that one is in small letter and one is in second letter, in capital letter. So if you now tell R, I need you to print the one in capital letter, it will now go and look for that place where you have paid and just print the one that has a capital letter or that are in capital letter. So if I decide to assign, okay, let's say this is my paid, and I decide to assign a variable name to it, and I decide to say okay 0.5, right, and I run, it's been saved, right? So whenever I say print paid in capital letter, consider 0.5 will come out, right? You can see them here. So these are the different naming rules you need to you need to have stuck to your brain, right? Before you naming or before assigning any variable name to what R. Number one, every variable name must begin with a letter or a period and not numbers, right? Number two, the variable name can contain letters, numbers, underscore, but not what spaces. Number three, variable names are case sensitive. So if I start with a small letter or all my letters are small letter, when I want to reference it or when I want to use it in later analysis or later referencing, I should stick to the method or to the way or to the case I use in writing it. Do you all get it? Do you all get that? Do you all get that?
Yes, I did, please.
Okay. So we'll move over to the next one. So now I've taught you how to print. So when you want to print your variable name, you just say print that variable name. So I'll be moving to the next one, which says data type, right? So now R supports various data type for storing different kinds of information, right? So below are the most common ones, right? So everything you see in R are referred to as objects, right? So all of the write up, all of our codes that we use in R are generally referred to as objects, right? So in case you see any places where you maybe are reading a R project book and you say the objects there, so it's referring to all of the codes that you are writing in R. So now before you can understand R or understand the codings very well, you need to know the basics, and that is you start with what the data types in R. So data types in R. So R supports various data types for storing different kinds of information. Below are the most popular ones. So number one is our numeric, right? We all know that numerics means number, right? Anything that has to do with counting numbers are numeric numbers, right? So the numeric numbers are stored in both integers and floating points, right? So your integers are the one with the L. Don't let this confuse you. Integers are the one with L. So if you have L in front of you here, if I put an L here, it's an integer. But when I have 10.5 in decimal, when I have numbers in decimals, they are called floating numbers. Then when I have numbers in just whole numbers, they are referred to as what? Numeric number. That's whole numbers, right? The second one is integer. You can see where we have an integer here. So like, let me cancel, remove this L and put these as numbers. or whole number. They name it as whole number. So now the integers specifically used for integers in R, and integer denote with the suffix sign L. So wherever you see a numeric number and it has a suffix alphabet, capital letter L at the ending, you should know that that is an integer, right? So we have under numeric, we have whole numbers and decimals, which are also called decimals are also called floating numbers. But number two kind of data type in R is our integers. The integers are also called numeric numbers, but the only difference between the numeric numbers and the integers is that is the presence of the capital letter A and the suffix right at the ending part. Number three is our character. Our character are mostly text. So our character are mostly text. They are used to store text or string values, right? So text values are values that are that are like phases or phrases, sorry, or are like sentence, right? While string values are just single numbers. So like you see now, a character usually have an opening code and a closing code. So if you store an information and you now decide to add an opening code and a closing code, R sees that as a character. So even if it's a numeric number, you now assign an opening code and a closing code. R will see that as a character and no longer a numeric number, right? So this one where I have name Josma Cell is a string value, right? Because it doesn't make any sense. It's just Josma, it's just a name. But a place where you now see hello world is a text, right? In like a text, let us call it a text, or yes, something that makes sense. Hello world, I'm greeting you, right? So you use them to store text and what string word values. Number four is our boolean. So boolean means true or false, right? It represents true or false values, often used for conditional statement like true and false. And you should know that whenever you are writing a boolean value or a boolean number or a boolean write up in R, which is true and false, they must all be in capital letters. So if you write them in small letters, or you just start with first letter is capital letter and the rest now becomes small, R sees them as error and it would not give them, if you don't apply the iPhone, it will not give them that boolean word data type. It will not classify them as a boolean data type, right? So for R to be able to see that, okay, I'm referring to true and false, I want to assign them to a logical what data type, then it must all be your true must all be in capital letter and your false will all be in what capital letter. Then the next one is complex. It is used to store complex numbers, right? So let's say you have imaginary numbers like 2 plus 3i. This is a complex number because the I there we don't know what it is, right? So it's a complex number is the real part 2 and the imaginary part 3. So 2 is a real number, but the 3 that has the I is an imaginary number because I could be anything. I could be trying to multiply 3 by I, which has a specific word value assigned to it, right? The number 6 is the factor. So a factor is also a textual value. They mostly occur in text, right? And are used to represent categorical data. So categorical data are textual data. Factors are useful for handling non-numeric data. So if you have data that are non-numeric or columns that are non-numeric with a fixed set of possible values that are level, those are called data. So when you have maybe a particular column that has just specific levels. So levels are like what is inside the column. Do I have two levels that are in repetition, right? So in the case of gender, where you have a column name called gender, you know that genders are just two, right? Male and female. But they can exist like 10 times or 20 times, depending on how many rows that are in that data. So the gender is your factor, then the male and female are your levels. So they are mostly used for statistical referencing, right? These factors. So most times when you want to convert a numeric data or into a factor or a textual data into a factor data or data type, they mostly do that when you want to use them for statistical um interpretation or references. So we now have date and time. Date and time. Arrow provides specialized classes for handling date and time. that is as date is to specify this particular code. This is have been assigned to a date, and as date and time you need to use the x the as pux tsv, right? So now let's go and see all of these data type that we have listed and see how we can come of it. So now, understanding data structure, data type. So number one is numeric. So numeric data type. So I'll be assigning numbers to it. So let's say I want to assign score. We can already have score. Okay, let me put my score in capital letter. So I'll say score 12, right? So when I run this, it will run. So if I want to check for if my data class, what kind of data class it has, I will then go for class. So there's a function called class, which is used to check for data type of a particular what information. So I'll go and put my score there. So let's see what class this has. You can see that it's a numeric what data, right? So even if I assign something now, let's say I assign R as my numeric data, right? So I'll say R and I put decimal point. So I'll say 12.9. Okay, to 1 to 1.9, and I run it, and I find look. Let's look for the class. So I'll say R. You can see that it's giving me what numeric, right? So because whether it exists in dots, in decimals, or it exists as a whole number, R sees it as a numeric data, right? Now the next one is integer. So integer. So now assigning numbers to an integer. So I'll say y. So I'll just say 20L. So remember that an integer already has a suffix at the end, which is already capital L. So when I run, it's going to run. Then when I say find the class, let's see what class is going to show us. So when I run this integer, right, you can see that because it has the L suffix, it now brought it as an integer. So if you do for, what else have you not done for? Boolean, that's logical. Right? So true and false. So if I assign egg to false and I assign yam to true, you can see that they are all in capital letter, and when they are in capital letter, R sees them as a Boolean character. So if I run this and I also run this, so let's look for the class. So I'll say class egg. So you can see that it's a logical character, right? So if I see say class and yam, you can see that it's a logical character, right? Hope you are all getting it. Hope you are following. Hope you are following. Please leave a thumbs up if you are following. If you are following what I'm teaching, leave a thumbs up. Okay. So the next one says complex. So I'd assign probably oil to complex. So I'll say 2 plus 3i. Right. So if I say class, you can see that has assigned a complex number to it, right? So these are ways you can assign numbers to it. So if I say the next one is factor, right? So I'm assigning gender to a factor. Then I put factor. For this one, you have to use the function to convert to a factor. So I'd say female, and I run. Okay, so I didn't put it in iPhone. Right? So if I say class, you can see that it's in a factor, right? So for you to be able to use this factor, you need to use the function factor to convert your textual data or categorical data into a factor so that R can be able to notify that it is a factor. Do you get that? So the next one is date and time. So I'm going to be assigning it something to a date and time. So I'm going to be saying Chris Chris. So to convert in for R to see a date as a date data type, right? You need to use the as date function, right? So I'm going to put it in brackets. I'm going to be saying 2025 02 06. Right, it has been saved as Chris. So if I say class, Chris, okay, I didn't run Chris. You can see that is a date. Do we all get that? Do we all get it? Right. So now we have come to the end of data structure. So now let's move into the next one. Sorry, we have come to the end of data type. So let's move into the next one, data structure. So there are different types of data structures we have in R. Number one is vector. Number two is list. Number three is data frame. Right. So now a vector is basically is a basic data structure in R used to store a sequence of values of the same type, right? So we have something called the numeric vectors and we have something called the character vectors. So let's go and understand what a vector really means. So I'll say understanding a vector houses is a data structure that houses or that stores elements of the same data types. And earlier we've discussed the meaning, we have seen the different types of data types that we have, right? So a vector is denoted is denoted by the C. Wherever you see C then bracket is called the vectors. Why C meaning, so C means, stands for combine. Right, so a vector is denoted by this function C, then the bracket, is housing the argument inside. So C stands for combine, right? So let's say, in our previous examples, we have not stored information that has more than one value, right? So let's say you want to store information that has more than one value. Let's say you want to store numeric values in five places, right? So probably scores of students, you have five students and their scores should be five in number, right? So you want to store it and keep it in a particular variable name called score, right? So the only way this can work and can be regarded as one is when you use your C combine, that's your vector to store information, right? And one thing you should know that two elements of different data type cannot fit into a vector. So whenever you want to assign a vector to a, or you want to store an element in a vector, you should ensure that they are elements of the same data type. So if you want to store five elements in a vector, you should ensure that all of them are numeric. If you want to be, if it's a numeric information, if it's a character information, you should ensure that all the elements you would store or you are storing in there are all character informations. If it's a logical information, you would ensure that all the elements, whether it's 5, whether it's 10, that you want to store in the vector and assign a variable name to it, are all what, logical format, right? So there are different kinds of vector. They are numeric, they are number vector, character vector. So let's start with number vector. So number vector, so when you talk about number vectors, that means housing more than one numeric value in a vector. That is called the number vector. So let's say I want to name this scores of students. Then let's say student score. Right, so student score. So now if I want to store, maybe I have five students and there are five stores where are already with me, and I want to store them into the variable name student score, so that I'm able to assign, I'm able to actually manipulate or always get hold of that information. I need my C combine. So I'm going to be saying C combine, and I'm going to be adding. So if I since I have five students and I want to write in their scores, I'll say 30, 50, 45, 70, then probably 35. And there are five in number. 1, 2, 3, 4, 5. But one thing I want to let you know, that if I did not use this vector, the C combine, to store this information, it's going to give me error. So if I store this kind of information without the C combine, you see the error message is going to produce. Right? I can see unexpected error in what, in this. But immediately I put my C combine, you see that it's able to store. So when I come down here, I would see student scores. Or haven't I run it? Okay, probably I've not run it. So if I come down here, right? So now I've run it. So if I say print student scores, so you can see that it has printed out all of the numbers. But without the C combined, it will not print. So this is called a number vector because all of the information inside of this vector are all numeric, right? So the next one is called a character vector. So I will just according to your type of data type now, a character vector. So I'll come down here and let's say I want to assign names or student name. So if I'm assigning a student name, so let's say since I have 5 scores, I want to assign the names of the 5 students. Right? Remember, text usually come with quotes. So I'm going to be saying Ola, Kelvin, Cynthia, Ade. When did you? No, no. My tummy is biting me. Your phone off.
My
My glasses. My glasses are broken. My glasses. You don't want me to see again. Tummy is biting me. I've not eaten anything since today. I will listen to this one of the get me. Let me and check whether it's let me and activate it.
Tommy is biting you. What now? What you want me to do, man? Time is 10.
Where's the name? Reconnected. Hello.
Hello, yeah.
Hello. Sorry, my network ceased. Can you hear me? Network don fuck up again. Inviting me.
Wait for 1 day. It's not inviting me. Just 1 day.
I'm recording. There's that one that I hate that triggered it. In fact, give me my phone, please. Hello, can you all hear me? Hello.
I can hear you.
Oh, okay.
I can hear
Sorry,
you.
the network.
Yeah.
Let me share my screen.
Okay. Okay.
I'm sharing my screen. So you can see my screen, right? Can you all see my screen?
Not. Yes. Yes.
Okay.
Yes. I can see.
So I'm going to be assigning characters or textual to this student name. So I have Ola, Kehinde, Cynthia, Ada, and the last one will be Edith. So you would see that this is we have assigned character vectors, or sorry, character vectors to student name, right? So when I say Prince student name, So you can see that we are having Ola, Kehinde, Cynthia, Ada, and what? Edet. So you do same for all of the data types, right? So now we can see that we have number vector, character vector, we still have logical vector. So you do it as data type continues. So you see logical vectors. So yeah, I'll assign maybe um let's say true or false. True or false. I'll give it the name true or false. So I'd say C, false, true, true, false, right? True. So if I say, so you see print. So you can see, okay, I've not run it. So when I run it, could not, okay, my print has capital letter P. So you can see false, true, false, true, false, right? They have been assigned to it. Do you get that? Are we all understanding it? Do we all understand it? Do we all?
Yes.
Okay. So now we're going to move over to the next one.
Okay.
So which has the list. So now the list can hold element of different data types, right? Unlike the vectors which hold only elements of the same data type. So if I'm combining like 5 elements, they must be numeric. So if I want to combine for vector, if I want to start with character, they must be characters, right? So now, but for list, I can do combination of all of them, right? So I can put a number, I can combine a numeric, a character, a logical, and that kind of vector to it together, right? So now let's go and see how a list can perform, because a list will just allow you to combine multiple vectors to multiple data of different elements together. So I'll come down to my R. So I would say understanding so for you to use list, so as C as vector has the function C then open bracket, so list also has its function. Like, so let's say I want to create a list of or let me just say a random list, right? So I'll just do random list, right? So I'll just, so I'm going to be using my list function, which is called list, right? And I would open a bracket. So I could now say I will now pick one numeric, one character vector, maybe Kelvin, and one logical, right? So when I run it, you see that it will run, right? So when I say print, so I'll say random. So you can see that it has printed it in form of a list. 30, Kelvin, and false. Do we see that? Can we see that? Can we see that? Okay. So now the next one is called the data frame, right? So the data frame is like a table-like structure used to store data in rows and in columns, where each column can be of different data type, right? So now let's say, we have most of us, I would have made use of seen data set, right? So let's say we are discussing or we want to analyze a beverage data set. A beverage data set contains columns, and all of those columns actually represent different data types, right? You could see a sales column which represents a numeric data type. You would see a country column which represents a character data type. You could also see a date column which represents a date data type, right? So now you can actually create something like a mini table on your own using the combination of a vector, right, and the function called the data frame. Now, so let's go and create a data frame together. So using the data frame function, right? So we're going to be creating something like a mini table for ourselves. So I'll come down to my R. Creating a data frame. So you'd see, let's create a data frame called sales data frame or sales table, right? So we name it sales. So I'll be using my data frames function, data dot frame. So you could see them here. So my first table will be called product, right? So I'll put equals to, then I'll use my vector so I can assign all of the same data type to that particular column called product. So my product will now be maybe Milo milk and so let's say sugar. So the next one is called maybe amount. So I would say 1 2 1 3 1 5, right? Then let's say the next one is called, we'll call the next one, so I've named product sugar, and let's say the next one will be called quantity. So I'd say C 1 5 10, right? So I would run. So I would say print sales. So you can see that I've gotten a data frame like this. Did we all see that? Did we all see that? Did we all understand that? Okay. So now we are going to come to the end. We are going to be ending our class here because it's already 10 o'clock and I need to go and rest for from today's stress. Right? So we should all keep in mind that our classes are on Thursdays by 8. See, I think we showed up so much very well today. Let me off this recording so it will not be too long.